Hey Science fam, this is Specific Heat Worksheet number 2, and we are going to bring everything together just to make sure that we are feeling confident with everything. So if we look at number 1 here, it says calculate the number of calories. So if we're looking for the number of calories, the question really is heat, right? How much heat or energy is being given off. So we need to look for that, and we want that in calories, so keep that in mind. Anyways, we have a few things, pieces of information that we know about. We've got 1550 grams of water. So right away, I know that I have a mass of 1550 grams of water. And this temperature of water has to be raised from 25 degrees Celsius to 75 degrees Celsius. So I know that my starting initial temperature is going to be 25 degrees Celsius. And I know my final ending temperature then would be 75 degrees Celsius. Okay, so I have all this information. I know then if I'm feeling change in temperature and all that, I got to use Q equals MC delta T. Now everything is there except for my C value. So I have to think about which C value would I use. Well, if I'm between 25 and 75 degrees Celsius, water is going to be liquid. So that means I would use the specific heat of water when it's in its liquid form, which is 4.184. Now notice that it's joules per gram degrees Celsius. So when I end up solving my answer is going to be in joules, and I want my answer eventually in calories. So that means once everything is done, I'm going to need to convert my joules into calories so that I can get the proper answer. Just to keep that in mind, it's going to be a little extra step. No big deal, nothing overwhelming. All right, let's start plugging in. We know that Q equals, or my heat equals mass times my specific heat times my change in temperature. Don't forget, change in temperature is always the final temperature minus the initial temperature. So my Q is going to be equal to the mass, 1550. I know that my C value, my specific heat, is 4.184. Just keep in mind that that has joules in it, so my answer will eventually be in joules. And my change in temperature, my final temp is 75. My initial temperature is 25. Now that I have that, I'm going to start chipping away at this. If I do these first two numbers, 1550 times 4.184, I get something a little bit bigger. I get 6,485.2 in my calculator. And when I subtract 75 from 25, I end up with 50. Now that I have that, I'm going to multiply those two together, and I do get a fairly large number. I get, let's see, what is this? 324,260 joules of energy. Now that, wow, sounds like a lot, but you know, you have about 1.5 kilograms of water, so you have quite a bit of water. And don't forget, a joule is extremely small of a unit. So now that we're in joules, we do need to calculate this into calories because that's what the question asked. How many calories? So let's do that. I'm going to always take what I'm given, which is 324,260 joules, right? That was my answer. But now I don't want that answer in joules, so I have to cancel out my joules by putting it at the bottom. And I'll put calories at the top because that's what I'm looking for is in my answer is calories. Now I know that for every 1 calorie, there's 4.184 joules of energy. Fine. So when I do that, notice that my joules will cancel out and I'll be left with units of calories, which is exactly what I want for my answer. So when I do that, 324,260 divided by 4.184, what I end up getting is about 77,500 calories. And that becomes my answer. All right, so by doing so, I plugged into my equation, got my answer, paid attention to my units, which were in joules, and then I converted those joules to calories using the conversion factor for every 1 calorie. It's 4.184 joules. All right, so hopefully this helped you with another specific heat type question, and let's move on to number 2. Question number 2 says, if I have 1 teaspoon of sugar, it produces approximately 16 food calories of energy. Okay. So first of all, I have 16 food calories. That's a capital C. That's for my energy. I want to calculate the number of calories, kilocalories, and joules that this represents. Okay, so I want to take this calories and convert it to little science calories, convert it into kilocalories, and convert it into joules. So this becomes a 3-in-1 problem, but pretty straightforward as far as just converting. Okay, so let's start with food calories into science calories, all right? I know that for every one big food calorie, there is 1,000 little science calories. Okay, so let's start with that. 16 food calories. I want to get rid of the capital C, food calories, and get into lowercase calories. For every one food calorie, there's 1,000 of the little calories. And the reason I put big calories on the top and bottom were to cancel out, so I'd be left with the units that I'm looking for. And in this case, 16 times 1,000 ends up being 16,000 calories. All right, so check. That one's done. Next is kilocalories. Now, I don't know if you recall, but remember, a food calorie is 1,000 times bigger than a regular science calorie. And 1,000 times bigger than a regular science calorie is also the same as a kilocalorie. So for every one food calorie is 1 kilocalorie. So if I have 16 food calories, it's the same as saying I have 16 kilocalories. So check, that one's already done too. Kilocalories is the same size as food calories. So I'm good there. Now the last one will take a little bit more work. I know that there is 4.184 joules for every 1 science calorie. Okay, so I need my answer in science calories, but lucky for me, I already figured that out. So let me take my 16,000 science calories that I converted from kilocalories, and let me convert that into joules. Notice once again, there's no equation for it. I just put calories on the bottom so it cancel out, and joules left up on top so that I can get my answer in the proper unit. I know that for every 1 calorie, there is 4.184 joules. So let me see. I'm going to do 16,000 times 4.184 divided by 1. And when I do that, let's see, what am I going to end up getting? My answer ends up being about 66,944, and my units will be in joules. So I converted to that as well. Nice. So I did 3 different conversions, all using my different conversion factors that I know. For every 1 food calorie, there's 1,000 science calories. 1 food calorie and 1 kilocalorie are equal to each other. They're the same thing. And there's 4.184 joules for every 1 science calorie. All right, let's move on to the third and final question. All right, this one looks like we're going to be dealing with specific heat again, but let me see. How much heat in joules? So right away, I'm looking for joules in my answer. So that means I'm looking for heat. Okay, so Q is what I think I'll be solving for. To raise the temperature of 25 grams of ice. So first of all, I know that I've got 25 grams of ice. And if I'm dealing with ice, I'm just in case going to look up my value for specific heat, but I have a feeling I'm going to be using it. The specific heat for ice is 2.03. Not nearly as high as liquid water, but still, ice has a pretty decent specific heat. All right, what else do I know from my information? It's going to be from negative 15 degrees Celsius to 0 degrees Celsius. It's going to be heated. So that means it looks like my starting temperature is going to be negative 15 degrees Celsius, and my final temperature is going to be 0 degrees Celsius. Now, the nice thing is, unlike gas laws, we don't have to convert our Celsius to Kelvin. We can leave that. So that's a little nice extra perk. But now that I have all that information, I'm looking for Q. So let's set up our equation. Q is equal to mass, or the heat is equal to mass times the specific heat times the change in temperature, which is final minus initial temperature. All right, let me start plugging in. My Q value is what I'm solving for. I've got 25 grams of ice. Ice is specific heat is 2.03. And my change in temperature, final minus initial, is 0 minus a negative 15. Careful, what happens when you subtract a negative? It becomes positive, right? So 0 minus a negative 15 is really just 15. So keep that in mind. And when I do 25 times 2.03, I end up getting about 50.75. Sorry, I'm getting a little close in all my writing, but we'll get through it. So now that I have that, 50.75 times 15, I end up getting about 761.25 joules. And that ends up being my answer as far as how much heat. So 761.25 joules. Would you be able to convert that to food calories, to science calories, to kilocalories if I asked you to? If you could do that, no problem, and know how to cancel out your units, you're sitting well also. But make sure that you do understand your equation for specific heat and how it relates to energy. And the important part, that it's always final temperature minus initial temperature. But if you're digging Q equals MC delta T, the change in temperature, things should be going really smoothly for you, okay? All right, guys, thanks for listening. Hopefully this makes sense. Always feel free to email me or ask questions in class if you need anything at all. Take care.